In the previous video, I actually realized that maybe I should have shown you something else, and that's just some convenience functions with creating matrices of certain types. So that's what I want to do now. So let me clear. Okay, so the first function that is very convenient is this function called zeros. Zeros, okay? And zeros makes a matrix of a certain type depending on what number you put in. So if I put in 8, then it gives me an 8 by 8 matrix where all the elements are 0. If I type 8 zeros 8 dash comma 3, then it will give me an 8 by 3 matrix of all zeros, and that's nice. I don't think it's necessarily nice because there's all zeros there, but it is nice because when we start to make functions that accumulate data, it's very good to allocate the memory up front. So as you know, uh, the 8 by 3 matrix contains doubles, and it's allocating memory for that, and if we do that up front, then there's a performance benefit for doing it. So we do these things because it makes our programs run faster, and if you speak to any computer science buddy that you might have, you realize that they're always trying to look for speed and make things go faster. So that's why we do it. Zeros is a nice way of allocating memory up front. There's another function called ones. So let me just clear everything. So there's another function called ones, which is like zeros, except it makes a matrix of ones as opposed to zeros, right? And so I can again also do ones 8 by 3. If I type it in, it actually takes up the same amount of memory because all of the elements inside are just doubles. Okay, and actually I think I have the suspicion that the zeros function is probably just ones times 0. Whoops. Ones, let's say 8.3 times 0. Then I'm just getting a zeros matrix. So I have a feeling that what's happening internally with MATLAB is that the zeros function is actually just a ones function multiplied by 0. So ones is nice too, because sometimes I want to do that. I want to do exactly this, but I want to multiply by some number. Let's say pi. Negative pi. Okay, and then I get negative pi in every element. Sometimes I want to do this. I want to actually multiply by not a number and sort of make a matrix where none of the elements make sense. And as I create a program, I fill in different elements with numbers or something that do make sense, and then I can sort out this matrix in terms of the nonsensical data and the sensical data, and that's helpful for me. So ones is a very nice way of making a uniform data set that I can use to represent data. And again, I'm allocating memory up front, so things are nice and fast. The last one I want to do is RAND. So RAND stands for random. Okay, if I type in RAND, the function, and I put in a number, then it generates a random number. Well, it generates a matrix of random numbers that are scaled between 0 and 1. So as you can see, every single number inside this matrix is scaled between 0 and 1. And random numbers are very important for scientific computing in general. If you ever do a lot of simulation work, you work for NASA and so on, you end up doing a lot of scenario planning or optimization and so on. And so there's a big class of problems or solution methods called Monte Carlo solution methods, so after Monte Carlo, the gambling of random numbers and so on. So RAND 3 by 2 will make 3 by 2. We'll make a 3 by 2 matrix of random numbers, and that's always nice to have. So those are the three functions I just wanted to go over. They're very convenient: zeros, ones, and RAND. And as we do more complex problems, we'll need to employ these functions.